Hi, my name is Emily Wilson, and I'm going to tell you about gravitational collapse and the birth and death of stars. So once upon a time, there was just this cloud of dust floating around in space. Dust and gas so small that it's the lightest thing in the universe. And they're just coexisting for a moment as one big, beautiful cosmic cloud. Well, one day, a star explodes, and the energy that it provides comes sweeping forward towards this cloud. It just sends the whole thing swirling and spiraling, and it makes everything move and clump together. Well, this clumping motion is the gravitational collapse, and it's what pulls everything together. So, if you imagine that the universe is just a snowy day, and you make a snowball and send it rolling down a hill. Your snowball is this little clump of dust that formed out of a dust cloud, and you are the dying star that brought it there. And it's not a very tightly packed ball either. It's pretty lightweight. If you threw it at your friend, it would just explode on impact. Like, there's nothing much holding it together. We start rolling it down the hill. And as it rolls, it grows and grows and adds more and more snow until it becomes this giant snow boulder that would crush your friends if it hit them. Well, that's how stars are made too. They're just clumps of dust spinning incredibly fast and pulling in all the dust around them. And the more they pull, the bigger they get. And the bigger they get, the harder they pull. And the harder they pull, the faster things fall toward them until everything is moving so fast that it heats up to millions of degrees. And all the little dust particles are moving so fast that when they bump into each other, it creates a huge explosion. I'm getting a little off topic here. The force of these explosions keeps the sun from collapsing any further. The explosions push outwards while the gravitational collapse is pushing inwards. So the sun stabilizes and we're just left with this ever-spinning ball, only now it's on fire. And this is happening every day. The light of newborn stars travels thousands of years to get to us, our little blue planet in the Milky Way, so that by the time we're seeing it, the sun has already been formed for thousands of years. And the same goes for dying stars, too. We don't know that it has happened until after it's already happened. But we do know how it happened, and the gravitational collapse plays a huge role in that, too. You see, you have this big ball of fire, just floating in space. But the problem is that fires can't keep burning forever. Eventually they run out of fuel and die out. Well, when this happens, you don't have anything to counteract the force of gravitational collapse. So the sun starts pushing in on itself again. Only this time it's a little different. It's not floating around in this big cloud of dust anymore because whatever the sun didn't use in its creation swirled together to form other planets and other stars off in the distance. So gravity starts to pull on the star itself, making it smaller and hotter. And with smaller stars, that's okay. They just become smaller, hotter stars until they eventually burn up. But with the bigger stars, this is a big problem. Because with the bigger stars, they're so massive that there's so much that needs to be pulled towards the center that all of the dust particles don't have any room to move anymore. So they just form in one giant lump of iron in the center. And this lump of iron grows and grows like a tumor until the star can't contain it anymore. And then, faster than you can blink, in one mere second, the whole star just collapses in on itself and creates an explosion so big that they had to make a new name for it. That's a supernova. That's right, you heard it from me first, folks. Big stars get cancer so bad they implode. So the energy wave from the supernova just spreads out and starts the whole process all over again, interacting with some other dust cloud some other distance away and spiraling it into motion to create a new sun. In the aftermath of the supernova, there is a bit of the star left, but it kind of changes its entire atomic structure. After the supernova, depending on how big a star was, it will either become a neutron star or a black hole. So that's all I have for you today on gravitational collapse. If you want me to research more about neutron stars or black holes and try to explain that one, please let me know down in the comments section and I will look into it. So remember, Gravitational collapse is defined as dispersed matter drawing itself together because of gravity. It causes cosmic dust to form into suns and planets, and then those suns implode because gravity. Thanks for watching. I had a whole lot of fun making this video. I chose this topic for a couple of reasons. First, it's because I'm super excited about space in general, but especially how something can be formed out of seemingly nothing, how a planet, a whole solar system, and life forms are all just derived from dust floating around in the void. And the second reason why I chose this was actually because I really liked the idea of describing a dying star as getting cancer so bad it implodes. When I read the description about it, I laughed because that's the image that came into my head, and I figured that if I thought it was interesting, then other people would find it interesting too. I don't think there was anything that was particularly hard for me to understand in this section, because gravitational collapse is pretty straightforward. It's gravity making things collapse. The hardest part of this video was trying to express my thoughts in a way that they could be explained to people who have absolutely no experience with physics, but at the same time trying not to sound too condescending in my explanation. So thanks again for watching this video. If you liked it, leave a thumbs up. If you want me to make more videos like this, do more research about different topics, please let me know in the comment section and I'll do my best. But for now, bye!